All right, let's walk through the development of the law of cosines. So I've got an arbitrary triangle. Not right. And let's try that again. Okay, so I've just got some triangle. I'm going to label it up. So angle alpha, angle beta, and equal gamma. And that means A, B, and C. Now, what we're doing is we're actually developing an alternative, an additional tool for our toolbox. The law of sines is pretty good, really good, and it gives us a lot of power, but we need something different. We need a law of cosines. And one of the reasons we need a law of cosines is if we've got two sides and the included angle, then we can get to the law of sines, but it gets a lot more tricky. And we end up with a lot more equations to solve. So we're gonna develop the law of cosines. So what I've done is I've labeled my triangle, I've dropped a vertical, and I'm going to again label my sides here, and I'm going to think about these resulting right triangles, right? So I've got the blue one and the yellow one. And these are two right triangles that share a vertical leg. So we know from the Pythagorean theorem that I can write that h squared plus x squared equals c squared, and that h squared plus b minus x squared equals a squared. Now I can solve both of these for h squared, right? So this top one tells me that h squared is equal to c squared minus x squared, and h squared equals a squared minus b minus x squared. Now that means that the right-hand sides of these two things have to be equal. So what I end up with is c squared minus x squared is equal to a squared minus b minus x squared. Let's solve this for c squared. So that means that c squared is equal to a squared that's what this says. Give me a sec. I think I made a mistake. Well, we'll figure it. We'll keep going. A squared minus b squared. Oh no, I'm okay. I'm okay. So let's do this. Minus b minus x quantity squared plus x squared. So I've got a squared minus b squared minus 2bx plus x squared plus x squared. Distribute that negative sign through. Got a squared minus b squared plus 2bx minus x squared plus x squared, so those cancel. So I've got c squared equals a squared minus b squared plus 2bx. Okay. Now, what I'd really like to do is make this look more like the Pythagorean theorem. So let's add b squared and subtract 2bx from both sides. So now I get that a squared equals b squared plus c squared minus 2bx. Well, that's great, but what do I do about that x? Well, let's think about x. x is in that blue right triangle with alpha. Oh, I like that. So, and x is adjacent to alpha, so we know the cosine of alpha is equal to x over c, or more helpfully, x equals c times the cosine of alpha. So I can come back down here, and I've got a squared equals b squared plus c squared minus 2bc times the cosine of alpha. And this is the law of cosines. We have also perhaps previously encountered this as the generalized Pythagorean theorem. What it says is the square of the length of one side of a triangle is equal to the sums of the squares of the lengths of the other two sides minus 2 times the product of those two sides times the cosine of the angle between them. So in generalized form, what we have, and this is true, it does not matter which side you label as A, B, or C. Your law of cosines is stated as such. All right, so if you've got two sides of a triangle and the angle between them, then you can use the law of cosines to find the third angle. And then you can use the law of sines to completely solve the triangle. So let's give it a shot. We'll come back in the next video and do that.